Good evening, friends. Today, we are going to cover a very important topic and interesting also. The When you go to the PLSM, SmartPLS, and let's say, open any model. So I'm opening this SAM model. And if you go to the calculate, so you can see the fourth option, importance, performance, map analysis. So we are going to cover this topic today. So we have covered PLS algorithm, bootstrap, CTA, PLS predict. So now, first of all, we have to cover this topic. In this case, there are two things. One is important analysis, and the second is performance analysis. So we have to understand two aspects, the importance analysis and the performance analysis. So first, we will understand the theoretical aspect of that, and then we will see how we can perform IPMA. So in short, we call it IPMA. So this is the topic for today. So we are going to cover two issues. One is called importance and second is called performance. And it is actually a map. So if you see this map, this is a map provided by the software, like importance, performance map. And on the y-axis, we are having the performance. And on the x-axis, we are having the importance. So you can check this importance, but this is performance, and this is importance. So two aspects we are going to cover. Now, whenever you run a model, so you already have a PLS model. Now, suppose somebody asks you two questions. Number one, to which independent construct the respondent have the maximum agreement? So we are using the word agreement. And second question is, which independent construct have maximum impact? So here the important word is impact. So these two answers will be given by the IPMA analysis. So to which independent construct the respondent have maximum agreement and which independent construct have maximum impact? So agreement is known as performance and the impact is known as importance. So agreement is known as performance and impact is known as importance. So these two are the important aspect of the SAM model, and it adds value to the information. And this is also a graph, but I am showing you the graph which we normally put in the paper. So this is one of the format that in this graph, the dependent variable is trust on SMI. So this is a output of a research. So in this paper, there are, that social media influencers. There are a lot of social media influencers who are posting the post on Instagram and other social medias. Now, this research focuses on that how they impact on the customer response. So whether, because for example, if some social media influencers say that this cream is very good or this food is very tasty, whether the consumer respond to it or not. So that was the question. So trust on SMI was the dependent construct, and these are the 5 independent constructs, like how much the entertainment value in the post, how much is the information value in the post, attractiveness of SMI, so whether the social media influencer is attractive, expertise. So like for example, there are many gym trainers, they are posting about exercises. There are many doctors, they're posting about health issues, so like that. So whether the expertise of MI is important, then trustworthiness of SMI. So these, all these are independent construct and measured by the items. So we are interested to know two aspects. One is the agreement. So where the respondent are maximum agree. Like if whenever you fill a questionnaire, every statement is asked in 1 to 5 scale, let's say. And in the 1 to 5 scale, 1 means strongly disagree and 5 means strongly agree. So if most of the participants, most of the respondent click on 4 out of 5, so it means most of the respondent are agree. So the level of agreement is very high. If most of the respondent click on 2, it means they are disagree. So the average of these statements indicate about the performance or indicate about their agreement. So this is one. And beta, because whenever you run the structural equation model, the software give you the value of path coefficient. The path coefficient is indicating the impact. Whether the impact, higher the path coefficient, higher the impact. So in this way, we calculate the beta showing the impact, and the agreement is represented by the mean. So we combine both of them into this graph. If you see y-axis, in y-axis, we are having the highest value of information value. Information value, this yellow dot is having the highest value. If you take it to the y side, so it is around 75. So it means 75% of the respondent are agree with the information value. So they agree that the SMI is giving some information, meaningful information. Then expertise of SMI, they believe that most of the social media influencers are experts. So they have expertise on whatever they are posting. And the lowest value is trustworthiness. So like you can see, you can take it to the y-axis, and only 40% of the respondent are agree that they are trustworthy. So the y-axis is representing the, if you see from y-axis side, so we can say most agreement lies in the information value, and lies least agreement lies in the trustworthiness. So if we see from the y-axis point of view, now if I see from x-axis point of view, the expertise of SME is having the maximum impact, trustworthiness second most impact, attractiveness of SMI are third impact. The least impact comes from the entertainment value. Means customer response is found to be least affected by entertainment value. Customer response is maximum impacted by expertise and trustworthiness. Higher the trustworthiness, more is the impact. So two answers we can give from this graph. So today we will see the different aspect of this graph. So I am showing you two things. First of all, let me show you the data. And so I will share this file IPMA SQ. SQ is representing the service quality. So in this data set, I'm showing you the data set first. The 10 means tangibility. Responsiveness, RES means responsiveness. EMP means empathy. So REL is reliability, assurance, and the last is service quality. So we are going to find out that where the respondent have the maximum agreement and which variable, which construct is having the maximum impact on service quality. So both questions we will solve in one answer. So first of all, I will take this to the SmartPLS and we do some calculations and then we will see the result. Like for example, this is the data and I have a construct called assurance. So first of all, I want to show you that how we can calculate the agreement. And here the agreement is coming in the scale of 1 to 100. So that is the different thing. Now I'm taking for demonstration assurance. So I'm taking assurance in this file. And now I'm going to tell you a very important formula for normalization. Okay. So there are four statements. And we are, first of all, we are converting them. So assurance, again, 1, 1. I'm just naming this assurance 2, 2, assurance 3, 3, assurance 4, 4. So what I'm doing, I'm showing you how to normalize any variable in the scale of 1 to 100. So this is a universal formula for converting any variable in the scale of 1 to 100. Let me write the formula first. The normalized value in the scale of 1 to 100 can be calculated by x minus minimum and maximum minus minimum. So I don't know whether you are aware about this formula or not. It is basically a statistics formula which can convert any variable in the scale of 1 to 100. So we are going to apply this formula on all the variables. So let me show you the calculation. So equal to, this is my x variable. You know that we are using the scale of 1 to 5. So minimum value is 1 and maximum value is 5. So I'm putting the minimum value 1 divided by 5 minus 1. Okay, so simple concept. So now I got this and just drag and drop. So we now you can see that all values comes in the range of 0 to 1. Similarly, I will do for all the three. So this 0.5 is representing for 3. This 0 is representing for 1. 1 minus 1 is 0. And this value is representing the normalized value for 3. So now let's drag and drop, and similarly I will do drag and drop. So now let's go to the last. So all the values are converted into 0 and 1. Now let's take the mean. So we can calculate the average. Average is the formula for calculating mean. And we are taking the values from here to the first value. So the mean is 67%. Similarly, I can do for all. So you can see that all the means are coming in the ratio in the scale of 1 to 0 to 1. 0 to 1. If you multiply by 100, it is in the scale of 1 to 100. And now I'm calculating the mean of mean, because these are the mean of individual statement of assurance. Now I'm calculating the mean of all the statement equal to average of all. So 66, the answer is 66. So now my answer is, so how I represent the 66? So I can say the agreement towards assurance, because I calculated for assurance, is 66 out of 100. So in the scale of 1 to 100, the agreement toward assurance is 66. So here I just calculated for one construct, but in the software, so software will calculate for all automatically. So this is just to tell you the formula how we can calculate the level of agreement. So because the how to normalize the variable, you must know, because we apply this formula in finance, in HR, in many cases. So whenever we want to normalize the values, so this is the best way. Okay. So one more thing I want to show you. Suppose I am making the same project. This is service quality IPMA. Create. So where it comes, okay. I have to name 0, service quality IPMA. If you type 0, it will come on the top. This one. Then import data. So we have to import the data first. And this is my data set. So click on the import. And going back, now I'm creating the model. So model is PLSM, and I'm putting the SAM model here. The name of the model is SAM. Save. So let's create the model first. So this is tangibility, hiding the indicators. Then this is, okay, RES. This is responsiveness. And all these are measuring the service quality. EMP is empathy. And then we have the reliability, assurance, and service quality. So we are having this model and joining all these independent variables. Okay, now connecting them. Okay, so this is my model. Now I am running. So first of all, I'm showing you one more thing. Just doing PLS algorithm. If I do just PLSM algorithm, and rather than calculating for the standardized, I go for unstandardized and run it. It will give me the construct scores. And you can see the latent variable comes here. Latent variables, click on the latent variable scores, copy to Excel, and I am pasting them in Excel file. Okay, so now I am applying the same formula again. In this way, you can also calculate, because we also know how to calculate in many ways. So this is assurance. Now I am applying the formula. This value minus minimum of the complete range. So this is the complete range divided by maximum value of B2. The range is B2 to B420 minus minimum value B2 to B420. So I apply this formula, and let me take to the bracket. Okay. So we have this value. Again, this value always comes between 0 and 1. So let's drag and drop. Yeah. So in this case, there is one mistake, because we have to put, you know, that when the values are fixed, we have to put dollar. So I am putting the dollar, otherwise the wrong value will come. I am pressing function F4 to converting them into the fixed values. Okay, now I think this is the better. Okay, so I will get the values. Only B2 is variable, all are converting it fine. Now, if I calculate the mean of it, I will expect the value 66. So you can see that the same value I will get 66. So only taking 2 decimal. So the agreement level can also be calculated by this method. So rather than taking the individual statement, you can also calculate the performance value like this. Okay. So I explained you how to calculate the performance values. So the first question, I hope you have the idea, to which independent construct the respondent have maximum agreement. So after this calculation, you know what is the meaning of agreement, how we calculate the agreement in the scale of 1 to 100. And let's see. So we are doing this exercise. And after this exercise, you can answer the 3 questions: that which independent construct have the maximum impact, which independent construct have the maximum impact on service quality. So I think this is repeated. To which independent construct the mean score is the highest. Okay, so this is the formula for calculation of the performance analysis. Performance calculation formula, I already explained that. X minus minimum, maximum minus minimum. So we can generate many graphs after that. Like, so this is the table we put in the paper, and I will show you how to make this table. So this is the table that you can put into the paper. Okay, so let me show in the SmartPLS. Now go to the calculate, go to the IPMA. This, you have to tell the software that what is my target construct. So which construct I'm going to explain. So here we are having only one endogenous, so I am putting SQ, IPMA result for all the constructs. And the software is showing you that what is the minimum value and the maximum value. Minimum value and the maximum value of all the construct statements. And let's perform it. So we are getting the answer. If you check the result section, first of all, let's see the map. So quality criteria is importance performance map. So this is the map we have to take to the thesis or the research paper. So I can take this map. Let's. I'm taking this snapshot. Snipping tool, with the help of snipping tool, I am taking this. Okay, and pasting in the Excel. So this is the first output. And after this output, because the one of the problem in this graph is that if you want to see that what is this green, then you have to see here, the green is tangibility. So to avoid this problem, we can do one thing, we can go to the insert. And after going to the insert, you can go to the text box and put the text box here and type tangibility. So most of the time, we have to make this text box. Similarly, you have to add the text box to all. So this is the one output that you have to paste in the thesis. Okay, let's move to the next. The software also give you the facility of customizing it. So if you go to the customize, so you can do a lot of customization like show legend. If you uncheck, it will go. And horizontal grid line, you can remove that. Vertical grid line. Okay, horizontal zero line, this line. So the software also gives you some options to make this chart beautiful. And the most important is the size. You can change the labeling also, label of the x-axis, labeling of the y-axis, and can increase the size of the circles. You can see that now they are big, and you can make them small. So sometimes we change this to make the chart more attractive. Okay, after this chart, now we will have the two different tables. So there are two tables you can see. One is the performance. So I am taking this table here. So this is the performance table. Performance is showing you the level of agreement. So I'm copying to Excel. So the result are here. And you can make a second graph like this. And I'm telling you this graph, whether you are applying IPMA or not. So this is one of the mandatory chart to be put in the thesis. And so I'm showing you how to convert this chart. Basically, we have to change this chart a little bit. Go to the design, click on the first chart, second chart, right click, format data series, fill, vary color by point. So this is the professional trick to make this chart better. And chart title is the agreement level. And then go to this plus, remove grid lines. So this is the chart normally we put in the thesis, and you can make this chart better. So this chart is showing you the where the respondent are more agree. So here you can see the tangibility. Toward the tangibility, the respondent have the maximum agreement with the statements, and to the reliability is found to be the least. So the respondent are least agree with the reliability of the service. So this is one of the important conclusion you can draw from here. And this is called performance analysis. And this analysis we are also reporting in this graph. So 70, you can see that 70, but here we are not having a lot of clarity. So clarity is there in the second graph. So this is known as performance analysis. Now we are coming to the importance analysis. So where is the table? So this is the performance analysis. Now we are showing you importance analysis. So go back to the PLS and go to the path coefficient. So there is no separate word for the importance. So we have to go for path coefficient. The path coefficient is showing you the importance. This is importance table. So I'm copying this table and taking to the Excel. So I'm making the graph here. Okay. Now the service quality is the dependent variable and all other are independent variable. So let me delete them. Even service quality, because it is a dependent variable, it should be deleted. Okay. Now you can make another graph to report the importance analysis. So insert recommended chart, and I'm taking again this chart. So it is a separate importance analysis, and now applying the commands. Okay, so select this chart design, second chart, then first chart. So it is a basically trick. First of all, we have to click on second chart, then first chart. Then on any bar, right click, format data series, fill, vary color by point, and go to plus, grid lines, and that's it. So this is importance analysis. So now your chart is ready. You can increase the font of the means. Okay, now what conclusion we are drawing from here? The tangibility is having the maximum impact on the service quality, and responsiveness is having the least impact on service quality. So now you can say that the highest impact comes from the tangibility, second highest impact is coming from the empathy, and third highest impact is coming from the assurance, and the least is coming from the responsiveness. And the same result we are getting from here. So you can check the highest effect of tangibility come at the rightmost side. So we can make individual graphs and we can make combined graphs. So highest impact is from tangibility, second highest impact is from empathy, the third highest impact is coming from the red, assurance, and the least impact is coming from the responsiveness. So we can do the importance analysis and the performance analysis very easily with the help of these three individual graphs. So we can create three graphs from here. And after that, in the final stage, we have to combine the tables. So I'm showing you how to combine the tables. So we have to take both table. I'm taking both the tables here. Table number 1, then table number 2. And from these table, I am combining. So I hope it is visible now. Okay. So this is the combined table I am making. So this is called performance, and this is importance. Okay. So performance is represented by agreement level, and this is represented by path coefficient. And here you can report the dependent variable, dependent construct, and this is independent construct or exogenous construct. This is exogenous construct, and so you can take this, and one is tangibility. So the dependent construct is service quality, and now agreement level you can take from here. And one is this, and the importance level is coming from this. Let me check insurance empathy. So the sequence is same like this. So your table is ready, and you can take this table along with the graphs in the research paper or a thesis. So in the thesis, whenever we apply the SAM SmartPLS, so we prefer to put these tables and graphs also in the thesis. And I have seen some papers where the researchers also included the result of the IPMA to add value to the result. So this is a short technique, and I hope you are having clarity on the importance and performance analysis, and you have also other options, like you can see the statement wise. Like if you click on the manifest variable performance, so you can calculate the agreement level of all the items. So you also have this in the result, and then importance performance graph, you have seen that. So this is the values, beta values, and this is the performance values. So these two tables we combined, and I think, yeah. So this is the item wise. So which item is more important and which item is less important for the service quality? Because sometimes it happens that the tangibility as a whole is important, but you can check also item wise. Like for example, green. So tangibility 1 is the most important. This black is tangibility 2, third most. So you can also do the importance performance map according to the items. So that is completely your choice. And so we have completed the topic. So thank you very much. So today we completed this small topic. I hope you like it. So that's it from my side. Give me a minute.